So in this exercise 1.4, we are going to discuss these type of problems, that is, prove that the following are irrationals. The given expressions we have to prove it as irrational numbers. Let us consider first one as a rational number. So if you consider it as rational, what is the form of rational numbers? Generally p by q. So let's consider 1 by root 2 as in the form of p by q, where p and q are belongs to integers and q not equal to 0. So now right there reciprocals are interchange them, root 2 by 1 which is equal to q by p. Here by comparing these terms, root 2 is equal to q, 1 is equal to p. 1 equal to p, okay. Why? Because p is a rational number, fine. But whereas q is equal to root 2, here root 2 is q, q must be what? Integer, but which is an irrational number, which is contradiction to our assumption that is 1 by root 2 is a rational. Hence, why this contradiction is arised? Because of our assumption. What is our assumption? What we have assumed here? 1 by root 2 as rational. Finally, what we reached here? We got, actually q must be what here? We should get as integer. But what we are getting? Irrational. So which is the contradiction to our assumption? Therefore, our assumption has taken rational, which is wrong. So what is to be considered? So 1 by root 2 is an irrational. Let us assume that root 3 plus root 5 is a rational number. That is root 3 plus root 5 which is equal to p by q. Generally rational numbers in the form of p by q, where you know that p comma q belongs to integers and q not equal to 0. Now square on both sides. By squaring on both sides, what you are going to get here? Let us observe. Root 3 plus root 5 whole square which is equal to p square by q square. So now expand this, which is in the form of a plus b whole square. So a square root 3 whole square plus b square root 5 whole square plus 2ab, that is 2 times of root 3 into root 5, which gives us p square upon q square. So here square and root you can cancel, square and root gets cancelled. 3 plus 5 in plus 2 times of root 3 into root 5, which gives us root 15, which is equal to p square by q square. Now 3 plus 5 gives us 8 plus 2 root 15, which is equal to p square by q square. We can transfer this plus 8 towards RHS, that is 2 root 15 which is equal to p square by q square minus 8. Now you are going to transfer even this 2 after simplifying this RHS. If you find LCM, what you are going to get it 8 into q square, that is 8q square by q square. Whereas we have 2 in this case, the 2 also can be transferred. Now it becomes 2q square. Here, if you observe, p comma q belongs to integers. That implies p square comma q square also integers. Therefore, p square minus 8q square by 2q square is a rational number, right? As RHS is rational, therefore LHS also must be, root 15 also must be a rational, but which is contradiction to the fact root 15 is an irrational number hence our assumption is wrong. Therefore, root 3 plus root 5 is an irrational number. 6 plus root 2 is a rational number. That is 6 plus root 2 equal to p by q, where p comma q belongs to integers and q must not be equal to 0. Now plus 6 if you transfer, root 2 becomes p by q minus 6. Here it is rational number, it is also rational numbers. Difference of two rational numbers also gives us rational number, which is equal to rational number. This is contradiction to the fact that is root 2 is an irrational number. Hence, our assumption is and 6 plus root 2 is an irrational number. Discuss exercise 1.4 in which first bit, fourth one, prove that root 5 is an irrational. So when single digit root 5 is given, how to prove? Let us see now. Here, let root 5 is a rational. Then root 5 is equal to, so what is the rational form of a number? That is generally denoted by p by q, where q not equal to 0. Here, let p and q have a common factor 1 other than 1, then let them convert into the simplest form as their HCF is 1. Then root 5 becomes a by b, where a comma b are co-primes. Co-primes as HCF of the numbers is 1, nothing but co-primes. So here first we assumed this root 5 is a rational which is in the form of p by q, where q not equal to 0. As it is not in the simplest form, as they have a common factor other than 1, then let us convert into the simplest form. When you convert into the simplest form, their HCF becomes 1. So now when you convert into simplest form, the rational converted into what? Which format? A by b. Let it be. And where a and b are what? Co-primes. Now square on both sides. So root 5 whole square, which is equal to a square by b square. As we squared on both sides, square and root gets cancelled. Then 5 is equal to a square by b square. When b square is transferred towards LHS, then 5 times of b square is equal to a square. Now you can observe that this a square is written as product of two terms, two numbers. Hence 5 is a factor of a square as well as b square also factor of a square. So that we can write as 5 divides a square according to the theorem 1.6. Therefore 5 also divides a. So as 5 divides a square and also a, then a can be written as 5 times of c. So dividend is equal to divisor into quotient in that format. A is equal to 5 times of c, where c is some constant. So squaring on both sides now. Then what does it become? A square is equal to 5c whole square, which is equal to 5 square and c square, which is equal to 25c square. Here a square also written as what? 25c square. But what is a square here? 5b square. So in place of this a square, we can substitute 5b square, that is 25c square. Now we can cancel this 5 once, 5 5s. That is b square is equal to 5 times of c square. Now in this case also there are two factors. The square of b written as product of two numbers, that is 5 and c square. Therefore 5 divides b square, that implies 5 also divides b. Now you can observe that 5 divides a, 5 divides b. That is 5 is the common factor of a and b. But what we written, a and b are both are co-primes. As they are co-primes, their HCF is only we must get as 1. But what we got here? Common factor as a 5. Hence, which is contradiction to our assumption. Therefore, what is the correct statement then? As 5 is the common factor we are getting, it is a contradiction to our assumption. So it is arised due to our wrong assumption. Hence root 5 is irrational. 3 plus 2 root 5. We need to prove that it is an irrational number. 3 plus 2 root 5 is an irrational number. So to prove 3 plus 2 root 5 is an irrational number, let us assume that 3 plus 2 root 5 is irrational. Then what is the form of rational numbers? 3 plus 2 root 5 can be written as p by q, where the denominator q must not be equal to 0. Now you can transfer this plus 3 towards right hand side. So 2 plus root 5, 2 root 5 is equal to p by q minus 3. 2 root 5 which is equal to p by q. If you find LCM, we can write it as minus 3q by q. So then it becomes 2 root 5 by p minus 3q by q. As we multiply 3 by q and divided by q, then it become what? P minus 3 root q by q, as q is common. Now we can transfer this into 2 towards right side. Then root 5 is equal to p minus 3q by q. So into 2 we need to transfer, it goes to denominator. So root 5 is equal to p minus 3q by tq. Here what did he observe? P and q are what? P and q are integers, right? Therefore what has become? P minus 3q by 2q is also becomes rational numbers. So root 5 leads to what? Is a rational number. It is contradiction to the fact that root 5 is what? Root 5 is an irrational number. So let us write here, it is contradicts to the fact that root 5 is an irrational. So here it is arised due to our wrong assumption. Hence, what is correct then? As our assumption is wrong, what we assume that this is an irrational number we assume, but what we achieve finally? Contradiction to the fact. What is the fact? Root 5 is irrational. So that our assumption is wrong. So what should be considered then? It is to be considered as what? Instead of rational number, 3 plus 2 root 5 is an irrational number. Let us see that the question is, prove that root p plus root q is an irrational number where p and q are what? Prime numbers. Whenever p and q are prime given, check that root p and root q, is their summation irrational or not. So in order to prove that, given that p and q are primes, therefore root p is an irrational and also root q is an irrational. So let us check their summation. Root p plus root q, which is equal to sum of two irrational numbers. Irrational numbers, therefore, which is also equal to what? Is an irrational number. Therefore, root p plus root q proved as irrational. Hence proved.